Welcome to the Explainer. Sometimes the most important documents are the ones we never get to see. Today, we're diving into one of those, a weekly checklist for an industrial engine room. And believe me, this thing is quite literally a matter of life and death.
So, you ever think about that? How all that food stays frozen solid? Well, the answer is hidden away in these massive engine rooms. We're talking huge, powerful, and, potentially very hazardous industrial systems working around the clock, totally out of sight. They're basically the invisible backbone of our entire food supply.
And the thing that keeps it all running safely, it's this document right here. It's the system's weekly health checkup. And yeah, at first glance, it just looks like a bunch of boxes to tick off a list. But as you're about to see, every single checkmark on here is absolutely critical.
All right, so let's get right into it. We're going to start with the core machinery, really the beating heart of this whole industrial refrigeration system.
So the first big section here on the checklist, it's all about the compressors. Now, these are the real workhorses, the heavy-duty engines driving this whole process. And as you can see, the inspection gets, well, pretty specific. So what is a compressor in this context? Think of it like a heart. It pumps the lifeblood of the entire cooling system, in this case, ammonia gas, through all its pipes and veins. Seriously, without these things running perfectly, the whole system just stops. And this is where the level of precision just gets wild. Look at that first check. Determine shaft seal leak rate. What does that even mean? It means a technician has to find and measure a leak that is so tiny it's almost impossible to see. So how tiny are we talking? Well, here's the number. The acceptable limit is 10 milliliters an hour. 10. To put that in perspective, that's less than a little plastic medicine cup you get from the pharmacy. The margin for error here is practically zero. And the stakes for this one little check are huge. If you're within that limit, great. The system is stable, it's safe. But if you go over, even by a little bit, you could be looking at a huge loss of refrigerant, system failure, or even a hazardous ammonia leak. It's a massive deal. But what I think is really cool is that the checklist isn't just about numbers. It actually relies on the technician's own senses. Listening for abnormal sounds or feeling for weird vibrations. An odd noise could be a worn-out bearing. A strange vibration, maybe a motor is about to give out. These aren't just casual notes. They are legitimate diagnostic tools that can stop a disaster before it even starts.
And of course, this same level of detail carries right on over to the refrigeration pumps. Just like the compressors, they're constantly checked for pressure, for weird sounds, for vibrations, all to make sure that the core of this system is running like a Swiss watch. Okay, so we've seen the heart of the system. Now let's move on and see how all this careful checking applies to the parts where the real cooling magic happens. All right, so now we're looking at the condensers and the evaporators. These are basically just giant heat exchangers. The condensers, they push heat out of the system, and the evaporators, they pull heat in from the freezers. And that's what makes everything cold. And you guessed it, they have their own whole list of critical checks. Take a look at this one, check here. Functionally test condensate drainline heater. I mean, that sounds so minor, right? A little heater for a drain line. But think about it. If that one tiny part fails, ice builds up, the drain gets blocked, and you could cripple an entire cooling unit. We're talking tons of food potentially spoiled. It just goes to show you, every single detail matters.
Okay, but this is where the checklist takes a really interesting turn. It pivots from just maintaining the machinery to actively protecting human life. See, this whole section here has nothing to do with how well the system is running. It's not about efficiency at all. It's 100% focused on what happens if something goes wrong. Because we have to remember, ammonia is a fantastic refrigerant, but it is really hazardous to people. And this part just shows the insane level of detail we're talking about. The check isn't just, yep, there's an eye wash station. Nope. It's, is the path to it totally clear? Is the sign easy to see? Is the water itself clean? Are the nozzles covered so they don't get gunked up? All of this is to make absolutely sure that if a technician gets exposed to ammonia, their first line of defense is going to work perfectly right when they need it. So really, when a technician is checking off these boxes, they're doing way more than just maintaining equipment. Every single checkmark is like a promise, It's a commitment to the safety of every single person who steps onto that floor. So let's zoom back out for a second. When you look at the whole document, what is this checklist really all about? What's the big takeaway here? Because it's so much more than just a list of chores, right? It's like a tool for precision engineering. It's a strict protocol for preventing a total disaster. It's physical proof of a safety-first culture. It's really a testament to all the unseen work that keeps our world running. And think about it. This is just one document for one hidden engine room. It kind of makes you wonder, doesn't it? What other invisible checklists and unsung guardians are out there right now, quietly and carefully, making sure our world runs safely every single day?